So, hello everyone, and welcome to this webinar where we're talking about how to secure your stack with Ubuntu. So, I'm Henry Coggill. I'm a product manager here at Canonical for security certifications, and I'm delighted to be joined by my colleague Ijlal Loutfi, all the way from Norway. Hey Ijlal, how are you doing?
I'm doing really well, Henry.
Excellent, excellent. Are you excited to be discussing Linux security today?
Every day is a good day to discuss Linux security, isn't it?
Indeed, indeed it is. Yeah, I've been working in this cybersecurity industry for coming on 20 years now, and this subject is more relevant today than it is ever. Yeah, I'm just based in the UK. Whereabouts is everyone else from? Anywhere exotic? Just let us know in the chats. It's always good to hear where our listeners are from.
Absolutely.
So let's have a quick look at the agenda for today, and we'll cover what we're going to talk about in this webinar. So obviously, it's a huge topic: security, Linux, Ubuntu, and there are bound to be things which we don't have time to cover. And if we don't, then just pop a question in the chat. Whatever platform you're on, and we'll do our best either to answer directly in the in the chat, or we can follow up via LinkedIn or YouTube, whatever platform you're on. So just let us know. Yeah, so let's crack on and have a quick look at the agenda, shall we? So next slide, please, Ijlal. Okay, so we're going to cover a quick overview about what operating system security means. We're going to talk about Linux, what the security implications of Linux are, what the threats are, and how it works. We can talk about how to fix some of the problems that people find, especially how to fix it in Linux, and some of the intricacies of the platform. We're going to talk about Ubuntu Pro and what that means and how it helps you with security. Then we're going to talk about the things that we don't know, some of the sort of the darker threats, and then Ijlal will cover some details of one of the most exciting topics in security that's hit us right now, which is confidential computing. If you don't know about this, then don't worry. It's brand new, and a lot of people haven't really come across it before. But it's a brand new paradigm in Linux security, and so we'll cover that too. So first up, I guess, Ijlal, why should we care about operating system security at all? What's the big deal?
And to answer it, I would like to invite all of you to meet my friend Pal. He works at Pal Bank, and for the next 6 months, he is going to be leading the development of Pal Bank's web application clients. So, question to you, Henry. Put yourself in the shoes of Pal. This is a highly visible application that will be handling definitely some security sensitive data. What practices would you think about putting in place for this project in order to make sure that it is really secure?
So a security project, I would make sure that I've got my development lifecycle is secure. I've got SDLC in place. I'd make sure my build pipelines are all running security scanning software. I would probably do static code analysis to make sure that I'm not doing anything that the people know about. Common problems like the OWASP problems. I would make sure my production systems are hardened. I would get my systems pen tested by some external parties. I'd make sure that the users access it via multi-factor authentication. I would encrypt all the data. Those are kind of the basics, I guess.
So,
yeah, it is.
That's a really good list. And to be just, for the fun of it, humor me for a second, and let's say that Pal or Henry will have unlimited resources and time to work on this web application, and that all of the great ideas that Henry just shared with us will be indeed implemented. So in the hypothetical ideal world, Pal client web application will be free, completely free of all known and unknown software vulnerabilities. And I'm posing the following question. Is this enough to ensure that the client's data will not be compromised? Unfortunately, the answer is no, or more accurately, while such efforts are essential, they are insufficient. The reason I'm saying that basically goes back to the fundamental notion in computing. Computers have been designed around privileged levels, in which the user space, the user land here referred to on the top of this picture as ring 3, is the execution environment where applications such as PAL Bank's web applications will be executing. And this is the least privilege level in computing. Underneath it, we find more privileged level software. I'm going to refer to it throughout this presentation as system software. Examples of this are obviously the operating system, namely its kernel, which it runs here in, as per this picture, in ring 0. Other privileged system software is the hypervisor if you are in a virtualized environment, and system management mode as well. So what's important to retain from this picture is this hierarchy of computing means that whatever runs in more privilege, for example, the kernel, will have by default and by design access to everything that runs on a less privileged ring. For example, the kernel simply has access to the user land, data, and code. Even if the data is encrypted, the encryption key has to live somewhere in the system, and the kernel will have access to that encryption key. So let's keep this notion of hierarchy of privileges in mind, and let's also reflect on it and understand really that we're not saying there is some bug, particularly in a particular computing environment, but this is just a feature. This is how computers work. So what this tells us effectively is it is great that you are investing in securing your application level software. It's great that Henry and Paul are going to invest all that money and time in making a software bug-free web app, but its security can be simply compromised when that web app will start executing and running on various client devices, because those devices have a more privileged system software. In particular, or of particular importance to us in this webinar, is that they have an operating system that runs in a higher privilege level, and that will be able to compromise it if things go wrong with the security of that particular operating system. So what we're saying effectively is that the OS, the operating system security, is the upper bound of your application security. Linux is a popular example of such operating systems. I would let Henry take us through its history and its current security posture.
Yeah, thanks, Ijlal. Yeah, I'll just give a bit of a potted history of Linux, and then we'll talk about how it fits together and what some of the security concerns are, and then maybe that will sort of provide some context to the sort of architectural diagram that Ijlal was showing. So Linux isn't really one thing. It more refers to sort of a group of operating systems which are all built using the same Linux kernel, and then a collection of open source software around it, which have all been bundled together into this distribution. So the distribution is essentially software that publishers such as Ubuntu or anybody really can make their own distribution, but they choose what software to sort of bundle together based on what they think people want, or what their users are asking for, or what their personal preferences are. And there are loads of different distros that have been produced over the years. New ones are still being created today, and other ones are sort of dying out. It is very much a live ecosystem. And Canonical has been part of this for a number of years now. So the company was started in 2004 in order to produce the Linux the distribution called Ubuntu, and we put out a new version of Ubuntu every 6 months, and this sort of release cadence has been the same over the last 20 years. So Ubuntu is based on the Debian distribution system, which is an even older Linux, which is also still going. Although this sort of 6 month release cycle is something that Ubuntu really champions. So yeah, we have a new version every 6 months, in April and October. But then also, not everyone wants to upgrade the system every 6 months. It's quite a burden to keep up to date. So that means every 2 years we have a long-term support version, which is something that then people could sort of know is going to be stable and going to be supported. And then we used to do 5 years of support for the long-term support distribution. This comes out every other even year. So the last long-term support version was Jammy Jellyfish in 2022. And at the moment, we're all furiously beavering away, looking forward to the next iteration of the long-term support, which is going to be called Noble Numbat, which is going to be 2404, and that's certainly taking up everyone's time. One of the differentiating features between a Linux distribution and some of the more traditional operating systems that we might be more familiar with is that actually with a Linux distro, it kind of includes all the software that you might need. And this means you don't need to sort of install the operating system and then download a whole bunch of random apps from different parts of the internet or different stores. You should be able to get all the software you need from one trusted source, which means you don't need to sort of introduce a lot of supply chain risk, which is is quite a big deal these days, particularly with the latest mandates from the from the White House about software supply chains. This is where a Linux distribution really comes into its fore. And just in terms of sort of how much is used, some people might think it's still a bit of a niche thing, a Linux distribution, but actually it's kind of everywhere. It's equally at home powering laptops. It's running mission critical applications in the cloud on your production servers. It's powering Android devices, smart TVs, robots on Mars, in-flight entertainment systems. So it's kind of everywhere. And it's big uses are on the clouds and in Android devices. So that's a bit about Linux, but what about security and maybe what are security vulnerabilities? So can you pop back a slide, please, Ijlal, for a second? I'm sure we're familiar with bugs, when the software doesn't work properly. The distribution packages all the software, like 25,000 applications plus in the Ubuntu ecosystem. Obviously, there are going to be bugs in this and things that don't work necessarily the way you want it to. But what makes a bug different from a security problem? Well, imagine a software bug in your email program. If it just means you can't read the email properly, that's a bug. But then if this, if there's a problem with the email program and then someone sends you an email and it takes your passwords and sends them off to an attacker, that's obviously a security vulnerability, and it sounds like a pretty bad one. So there's a way that people can measure this. And we have a system called the Common Vulnerability Scoring System, or CVSS. And this is basically a measure where you can rate an issue between 0 and 10. And that tells you how serious it is, whether it's a security problem or whether it's just an annoying bug. And this is based on a number of factors. One of them is the access vector for the problem, how difficult it is for someone to get and actually exploit the vulnerability in this piece of software. Do they need a network access? Do they have to be local? And there are some other factors such as complexity and does someone need to be logged in? Anyway, you put all these different values into a formula and it produces a score, and it tells you whether the issue is serious or whether it's not serious. And this, as I said, goes from 0 to 10. So typically, if a bug has a CVSS score of 10, that's the worst. So that email program I mentioned, that'll probably be up there with a 9 or a 10. Anyone can send you an email, and if it exploits your system and steals your password, that's a pretty bad vulnerability. But if it's much harder to exploit, maybe someone needs to get access to your machine and be logged in and then run some special commands, then that might be a lower severity issue, and that might be a 3 or a 4, and then maybe you don't need to to worry about it so much. But then part of what Canonical will offer as publisher of a distribution is that we look at all these security issues which might affect the packages within the Ubuntu ecosystem, and then our security team will triage them all, and then we'll verify that the CVSS score is accurate and we agree with it, and then the ones which we think are worth fixing, we'll fix them and make sure that people are patched straight away. So these software vulnerabilities and software bugs in general, they're an unavoidable fact of life, but it's how you deal with them that makes all the difference. No software system is ever going to be immune from security vulnerabilities, and it just means we need to keep the software up to date. Now, when it comes to security issues, we're showing a slide here which sort of talks about the number of issues that Sneak, who are independent software scanning vendor, they scanned a number of different applications, and I think these are containers, and they obviously found different numbers of vulnerabilities in different packages, and you see that Ubuntu definitely, we clear out all the high and critical vulnerabilities as soon as possible, to try and keep our users as secure as they can. I think the latest data, for some reason we don't publish it, but anecdotally we know that critical vulnerabilities are fixed within 24 hours within the Ubuntu ecosystem. And the nice thing about open source software is that we can be fully transparent about these security issues. You can see what's been fixed and when, because the source code is open for everyone to inspect, sort of by the nature of it being open source. And this kind of give you full a sort of, it can give you the confidence that, we've patched issues when we say we have, and no one's hiding anything away in the sort of the bits and bytes. So actually, the vast majority of these security vulnerabilities, they're discovered by researchers, independent researchers who study the software and report the issues. And they do this to kind of generally improve the software for everybody. They fix things. They want to make sure that the people are protected. And most people operate in a responsible disclosure model where the researcher will report the vulnerability to the software publisher or the upstream project, who then has a chance to fix them and then give everyone the patch. And then once everyone's deployed the patch, then they'll be able to tell the world about the vulnerability. And I guess the question is, why do people do this? Well, I think there are quite a few reasons. A lot of people want to make the world a safer place. I want to make sure that the software that I use, my family and friends can use it without being attacked and exploited. And people just want to make the software better. And you can publish your work and tell people that you found these these vulnerabilities and they've been fixed, and you can gain credit for it. Put it on your CV or resume, and this definitely works. So there's for example, there's quite a famous guy who found the first iPhone exploit, that allowed a jailbreak. He was called GeoHots. He became very well known. He got job offers from Facebook and Google, and then he ended up starting his own company. So it definitely works to get yourself known. And indeed, some companies will actually pay people to report security issues in their products, like via a bug bounty scheme. Typically, this is for closed source software and SaaS platforms. The more serious vulnerability that people find, the more money. And there are plenty of researchers who can make a good living finding vulnerabilities this way. For example, if you look at Apple's bug bounty program, they offer, I think last time I checked, it was like $1 million for a full remote code execution on a device with no user interactions. So like a CVSS score number 10, they would, if you find one of those problems, then they would give you $1 million. So it's definitely worth doing if you have that, the skills and the time. Unfortunately, not everybody operates like this, and there are some people who do live on the dark side. These malicious hackers, who you read about in the news, who discover vulnerabilities and they keep them for themselves, and they might sell them on to other people to use in zero-day attacks. And this is called zero-day because, the previous model I just mentioned about people fixing the vulnerabilities, in advance, the vendor has 0 days to react and release a patch. So that's kind of a quick overview of how vulnerabilities are found and discovered. But I guess, one question is, why don't people patch them all the time, vulnerabilities, and why there's still such a problem with unpatched systems? I don't know, Ijlal, do you have any thoughts on that subject?
Right. So let me first share a couple of statistics which I found to be super interesting, which speaks to this problem of having a vulnerability which is disclosed. So it's a known vulnerability. There is a patch available to mitigate it, and yet we hear routinely about exploits making use of these unpatched vulnerabilities in real world systems. So as much as 60% of data breaches are actually caused by unpatched vulnerabilities. That's a lot, isn't it? The second thing to note here is only 25% of organizations are successful in applying fixes to known vulnerabilities within 2 months. So the rest, I don't know how long it takes them, but it's definitely more than 2 months. And that's a large window of time for an attacker, a malicious attacker, to detect that you have a known vulnerability that is not patched and to make a successful exploitation of it. So the question which we ask from these statistics, just what's going on? Why don't you make use of the patches available to you to protect yourself? Is it just because you don't care? I think that's a facile conclusion. And my take on it is really there is a legitimate, genuine tension here that sysadmins and end users are struggling to resolve. There is a tension between finding a balance between security and usability, because the fact of the matter is patching vulnerabilities might require you to reboot your system. And you might have some workloads within your system which you do not necessarily want to reboot because of some SLAs you have to meet. for uptime. Maybe you're training some machine learning model and you want to just continue with that without stopping. So for all those reasons, within the Ubuntu ecosystem, we have a solution to resolve that usability security tension, and we call it Ubuntu Live Patch. So what it does is something very specific and very powerful. So it addresses head-on the kernel vulnerabilities. So any vulnerability that is ranked as high or critical, Live Patch will be able to resolve it, patch it at runtime without requiring you to reboot your system immediately. So the advantage of this is that you can stick to your default maintenance window, and you can defer reboots until the next scheduled one. So by reducing unscheduled reboots, and by addressing all those high and critical kernel vulnerabilities, which let me give you an idea of how many there are, because Live Patch is only for kernel, it's not for other types of software. But as much as 60% of all high and critical CVEs actually are within the kernel. So by using Live Patch, you're effectively closing a large gap, or you're addressing a big portion of those CVEs which would have required you to reboot unexpectedly anyways. So this is a testimony of the actual ROI that one of the users of Live Patch has shared with us. So apparently they're very happy with Live Patch. They have stated that as far as the cost, that it's highly cost effective, and that's manually migrating VMs, applying kernel updates the traditional way without Live Patch, which means you would have to reboot them, would take them on average 32 hours per server. Multiplied by 80 servers, that would have been 2,500 hours of work. So for them, saving this much man-hour is extremely valuable, and they can actually put that type of resources into doing actual digital or IT work, which adds direct business value to whatever business they are in, instead of just maintaining the security of systems, for which there is a solution. So if you have this constraint of keeping your system secure, which I know all of us want to do, but at the same time you want to stick to a well-planned maintenance window, Live Patch is highly recommended for addressing kernel vulnerabilities. The good news is it is available on both your x86 and S390 architectures. And it is also for Ubuntu specifically. We support it for our long-term support kernels, for our LTS kernels, but we also support it. We have started supporting it now in hardware enablement kernels, HWE kernels, starting with 6.2 on Ubuntu 2204. So HWE kernels, briefly on a very high level, are kernels which we initially released with our interim releases, our non-LTS releases, and then we make available on LTS Ubuntu in order for us to enable users to benefit from the hardware innovations that maybe they have acquired when they bought a new hardware. So these newest hardwares you can use them with our LTS kernels, and Live Patch is available for them. And this is the case for both desktop, public clouds, as well as if you are running Ubuntu on a private data center. Now, let's forget about Live Patch and go back to just the good old patching vulnerabilities in kernel and outside of the kernel, the normal traditional way. Ubuntu Pro. Please, Henry, tell us more about it.
Yeah, so I mean, hopefully we've convinced you now that it's it's critically important to fix those vulnerabilities, and so therefore it's it comes down to the choice of the software that you're using and finding out where it comes from to make sure that the software that you need to use, those packages, are kept up to date. And this is where we try to make it a safe choice on Ubuntu. So, like I mentioned in earlier in the discussion about Ubuntu generally, to start with, we offered 5 years of security maintenance on our sort of base set of packages, the main packages in the Ubuntu ecosystem, and obviously that's available to everybody. But then we realized that people maybe want more than 5 years, and so for our enterprise customers, we've come up with Ubuntu Pro, which extends that 5 years out to 10 years of security maintenance and support on all the packages, the 25,000 plus packages within the sort of universe ecosystem. And this is sort of really really compelling proposition for people. It means that all the software that you might need to consume in order to run your development environments, your production environments, the infrastructure underneath it, the Kubernetes, OpenStack, all these things, you can get all the software from the Ubuntu ecosystem. And with Ubuntu Pro, we'll make sure that everything is patched for 10 years. So obviously deploying in a production environment is a big engineering job. And once it's up and running, you want it to last. You don't want to sort of have to upgrade every 2 years. That would be pretty expensive to do. So this means with Ubuntu Pro, you can deploy your environment, and then you can know it's going to be secured for 10 years. And Ubuntu Pro then has sort of got you covered. Ijlal was mentioning the live patch. Obviously, we include that with Ubuntu Pro. And we've also got some other security hardening tools, such as complying with the CIS benchmarks. That's part of Ubuntu Pro. And if you need professional support from people who really understand Ubuntu, and who've got your back in case everything goes wrong, or something blows up in the middle of the night, Canonical can support you through that too. So hopefully that's that's our sort of enterprise offering there. But I mean, there are other parts of security too which we haven't covered yet. We've talked a lot about vulnerabilities, and this obviously refers to things that people know about, and you can patch. But what about unknown threats? The things we haven't seen, those 0 days, and the ones that people haven't discovered yet. Is there anything we can do to reduce the impact of those? Well, there are a range of technologies and practices that we can use to try and mitigate the risk of these exploits. And traditionally, a lot of these been in the class of memory corruption vulnerabilities, and these have plagued native code for a long time. I'm not going to go into huge amount of details here because it's a topic for a whole session on its own. But you can see a lot of these protection features on this screen here. They're talking about protecting the memory of programs, of the kernel particularly. And this is why the compiler will give you these sort of memory protection options. And this means that if a vulnerability is found in a piece of software that that we don't know about, or the upstream project doesn't know about, then these memory protection mechanisms mean that hopefully the vulnerability can't actually be exploited to harm the system. And I guess this also actually highlights another benefit of accessing all the software through one trusted source, such as the the Ubuntu ecosystem. So all our packages are compiled with all these memory protections in place by default. It all sort of adds up to try and help protect against these things which we don't know. Obviously, there's a little detail in this slide. Yeah, I mean, all this stuff is available, or is kind of enabled by default on all the packages that we ship. But as I mentioned in the agenda, there's one particularly interesting piece of technology which is coming onto the scene now called confidential computing. And as it happens, Ijlal is an expert on this topic. So I would like to hand over, and maybe you could tell us a little bit more about confidential computing and what it's going to mean for us.
Absolutely. Actually, let me go back to Ubuntu Pro, because I really liked seeing all the value proposition that it offers consolidated in one slide. And just to highlight that if you want to have access, it obviously gives you access to enterprise-grade security, but you can have it for free. You can have a subscription that you can use for free if you are personal users for up to 5 machines. So I highly encourage everybody to just go subscribe to Ubuntu Pro and give it a try to keep yourself secure, basically. Having said that, confidential computing. So remember the hierarchical levels that we talked about at the very beginning of this presentation, and how the kernel and every other privileged system software is able by default to read your application's code and data. Well, confidential computing is here to fundamentally disrupt that assumption. It's here to give control back to the application layer. And it does that by, there are actually 3 primitives: confidentiality, integrity, and attestation. And this slide is speaking to confidentiality. So we have had for so long primitives that would allow us to encrypt and safeguard our data when it is stored on the hard disk, on any other type of secondary memory. But when this data is brought from secondary memory to main memory, DRAM, for example, it would have to be in clear text if we are to perform any type of computation on it. So confidential computing is changing this, and what it allows us to do is to have data and code encrypted when it is in DRAM, basically. The way this is achieved is thanks to hardware silicon innovation. So if you see on the right side of this picture in the trust boundary perimeter, there is a component which usually was not present up until the most recent hardware. It was not present in the chipsets. So that's the MEE, the memory encryption engine. Typically, this is an AES 128 or more recently in AES 256, and it simply encrypts every memory read and write to and from the CPU to the DRAM. So effectively, it's a real-time encryption engine to the DRAM. And what this means is that we're not saying that the operating system will stop managing your application. Actually, it will continue being responsible for example, scheduling your process or scheduling your virtual machine. If the hypervisor can continue doing all that good stuff, which you don't have to worry about at the application layer, but it will cease to have access to your data in clear text. What it will have access to as an operating system or hypervisor is ciphertext. So as long as we trust that AES 128 has not been broken, then we can extend that trust under some other assumptions to say that the privileged system software does not have any more access to my privileged to my data, which runs at the less privileged ring 3. So that's a very powerful shift in the way security works in computing. And it's one that serves the benefits of end users and application developers. I've spoken to confidentiality in that slide. There are other access control, newer access control mechanisms which have been added to the memory, to the MUU, which I will talk about in a subsequent webinar. But here in today's presentation, I want to focus more on having enabled confidential computing, which we have spent a lot of time to do for Ubuntu. What do we offer today, and how can you get your hands on a confidential virtual machine if you have that type of workload which requires you to protect your data from its hosting environment? For example, you really want to make benefit of a public cloud provider infrastructure because public clouds are great, but you have worries, legitimate worries, that you want to prevent the operator of that public cloud or the hypervisor of that public cloud from compromising your workloads, effectively your VMs, data, and code. So today, we have the widest range of offerings of confidential computing VMs across the industry. So for Azure, for example, you can go into the marketplace, type in Ubuntu 2004 confidential VMs, and you will have that available by default. For you, the way you will consume this will be very user-friendly. It will be exactly like you would work with a normal non-confidential VM. And that's because Ubuntu has taken all the complexity away. We have enabled this. We have taken the enablement job and have baked it directly into our kernels, so that you can consume it in the same fashion as you would a non-confidential VM. So 2204 also available on Azure for confidential VMs. There are different silicon technologies and the hardware providers which have now hardware that ships with confidential computing capabilities. So we find AMD Sieve SNP, for example, but we also find Intel TGX. So for TGX, we have confidential VMs enabled on both Azure and Google Cloud. On Amazon, we also have AMD Sieve SNP enabled for Ubuntu 2304. Google Cloud also have AMD Sieve SNP. And we make sure in all of these to have the same user experience that you would in a non-confidential environment. So a very important point as well is confidential computing is very useful for the public cloud, and that's true, but it is also very useful in a data center setting, because in your data center, you are still running the same system or privileged system software that the public clouds are running. You still have your KMU, you still have your KVM, you still have a host operating system. And these are prone to security vulnerabilities, right? So if there is a mechanism that can allow you to protect your confidential VM or your workload from these host vulnerabilities, then you should take it. Another threat still within the data center that confidential computing can help you mitigate is insiders threats, right? So hopefully you trust to some extent the people who are managing your physical data center, but it would be even better if you could have strong cryptographic guarantees that these people cannot actually snoop into the data that you are running within the confidential VM. So we have a strategic partnership with Intel, which is allowing us to offer the end-to-end solution for private data center customers. Effectively, you can build with Ubuntu host to guest your confidential data center. We have already released in 2310 a private tech preview. Ubuntu as a host kernel. We have QEMU libvirts also supported through PPAs. And on the guest VM side, we have obviously the Ubuntu kernel, and then the OVMF as an in-guest CVM firmware. And this journey through the strategic partnership that we have with our Intel Silicon partners is going to continue all the way to 2404. So definitely stay tuned for more support for this feature in later releases of Ubuntu. So, Henry, is Linux secure?
Well, I think what we've tried to highlight so far is that, software these days is big, it's complicated, there's a lot going on. And actually, with the millions and millions of lines of code that go into any operating system and all the ecosystem of packages around it, no one can guarantee the security of anything. But it's about these values which we put up here. It's about openness, the fact that you can see the code, you can trust what we've done because we're not hiding anything. It's about transparency. We'll tell you what's going on. Agility, it's about the fact that we can respond to the vulnerabilities and fix them, as soon as we possibly can. We're fixing the critical vulnerabilities, those top CVs with the top CVSS scores, fixing them within 24 hours to make sure that you can get the patches installed as soon as possible before anyone's had a chance to attack your systems. And trustworthiness. Ubuntu has been around for 20 years. We're trusted by millions of people across the world to deploy their secure workloads. And we continue to work with the industry and the community, like Ijlal was saying, with confidential computing, to try and make sure that you can have the maximum possible trust in your workloads. So we can't guarantee that anything is 100% secure. I think anyone who tries to tell you that is probably hiding something. But we're doing our best, and we can give you, as it says here, we can give you this sort of enterprise-grade security maintenance, and if you want support as well, we've got some Ubuntu experts in our support team who can help you out. We've been doing it for 20 years. We're pushing out the new releases every 6 months or every 2 years if you want your long-term support, which then will give you covered for 10 years. If you need a support contract or anything for your sort of commercial legal purposes, we can set you up with that very easily. And we're not planning to go anywhere. Ubuntu is published by Canonical. The company is now 1,000 people, and we're still growing. We're still trying to publish open source software as easily and as securely as possible. So do you think that sums it up, Ijlal?
It does. And what I hear you saying, Henry, is Ubuntu is the most reasonably secure OS you can bet on. And that's a realistic statement we can stand behind. It's not only us, actually, a lot of millions of customers, our friend Val included, they continue to choose Canonical Ubuntu every day to power their desktops, their IoT devices, their data centers, and public cloud workloads, because they also agree with our conclusion.
So that I hope that has sort of given you a good summary of how to secure your stack based on Ubuntu, and I think we can probably now move to questions. I know we've had a few questions coming in on the chat channels on the different platforms. So if you've got any more questions that you think we haven't answered, just get them in now, and then we can start answering them as soon as possible. So there's one about live patches. Well, did you see that? Maybe you'd like to answer that question.
Yeah, let me read out the question first. So somebody wants to know about what happens during live patch. Are the processes suspended? So live patch relies on kernel modules, dynamic loading of kernel modules to get the patch into the kernel, and then function redirection in order to redirect the functions which would have otherwise used the old vulnerable code into the new loaded kernel module, which represents the patch which we want to introduce. And then every kernel, and this is architecture specific, has something called the consistency model in order to make sure that these redirections happen in an atomic manner that does not break the integrity or does not introduce any subtle security threats that can be leveraged then for building exploits based on this redirection.
So someone made a comment about, we mentioned the IBM's S390 platform in the live patch, and someone said, oh, mainframes, they thought they were dead. Well, actually, no, the S390 platform is still going strong. IBM, come out with the Z16 iteration. It's still being produced and it's still being used. So don't diss mainframes. They are still here, running a lot of the financial workloads of this world.
Yeah.
There was another question about the CIS benchmarks and hardening systems. I guess this is actually quite an involved topic, and I've done another webinar specifically about CIS benchmarks. Essentially, what this means is that we've got this Ubuntu operating system and all the software that you run on top of it. And because we don't know what people are going to use Ubuntu for or how they're going to build their systems, we give people fairly safe defaults. But you might use it in development, you might use it in production, you might use it on your laptop or on your Raspberry Pi. And we need to make sure that it works on all of those devices. But some people, if you're running a production environment and you're handling sensitive data, you might want to sort of tweak the system and lock it down to make sure that it's super controlled. And that's where these CIS benchmarks come in. So we work with this CIS, the Center for Internet Security, to define how to really lock down an Ubuntu system and make sure it's like super tightly controlled. And we've got this program called the Ubuntu Security Guide, USG, which will help you through that, and make sure that your system is as locked down as it can be. There's another question about using proprietary Intel technology and vendor lock-in for confidential computing. I guess, Ijlal, have you got any thoughts on that one?
So the enablement we do for confidential computing, whether that is with Intel, with AMD, obviously when I say enablement, it means we're taking some patches, and whether they're upstream or non-upstream, and then we're putting them by default into our kernels and then potentially into some user space like libvirt and QEMU. None of that stuff is proprietary. Everything that we do to enable confidential computing within Ubuntu is open source. Now, if we talk about the silicon and the hardware itself, that's something, because obviously we make confidential computing visible and consumable. Whatever the way that our silicon partners choose to make the technology available at the hardware level, it's something that sits outside of the Ubuntu boundary. So whatever they decide to do with, I don't know, the new firmware for the root of trust that they have in order to make confidential computing possible, really speaks to the way they handle every other thing they provide, every other innovation they provide through hardware. It is, we don't have a say in that, but what we can ensure is that our enablement work is fully open source.
Okay, I guess there are quite a few other questions about confidential computing, which is not surprising, really, because it's, as I said, it's a really hot topic, and it's got a huge potential. So there's a question about, does it come with a PCI DSS attestation? I think the answer to that is probably not yet. I mean, PCI DSS is obviously it's a compliance and security framework for financial transactions and people operating within, handling card data and financial data. So that has its own specific set of requirements. And last time I checked, I didn't see anything within PCI DSS specifically about confidential computing. It's probably a bit new. We might have to keep an eye on that one. I think, is that a fair comment as well?
It is. I'm going to pick on another question here, which touches on both our areas. So the question is, confidential VM FedRAMP compliant by any chance? If not, is there a plan? So
yeah, interesting. I mean, I think this is kind of similar to the previous question about PCI DSS. So FedRAMP is a security sort of framework based on the NIST 800-171 guidelines about operating a secure environment for service providers, who are offering their services to US government departments and agencies. So FedRAMP has a long list of requirements. Again, I don't think it mentions anything about confidential VMs specifically. I think one of the things that we could do would be to make sure that you could use the confidential VMs with things like FIPS 140 compliance, which currently we don't do, but it's on our sort of it's on our horizon. We know we need to do it eventually, but I guess it's this kind of intersection between brand new technology and regulation. Obviously, the technology steps ahead, and then the regulation takes some time to catch up. So as such, at the moment, there isn't specific FedRAMP support for confidential VMs, but we would definitely like to do that at some point. So there was a question about landscape, which is sort of Canonical's system management tool to how to sort of manage and deploy and update systems at scale. Is there any roadmap for landscape? I guess there is. We're probably not the right people to talk about landscape. Our colleague Rajan Patel is the right person, but we can maybe link in the comments to the latest that Rajan has put on that. I think also a couple of other questions about confidential computing, Ijlal. Which AES mode does it use? I think did you touch on that one?
Yeah, I think don't quote me on this, I think it's the AES ECB, but there is also some details about having address-based tweaks with AES as well. Yeah, I would have to refer back to the documentation to give you an exact answer, but feel free to do that as well.
Okay. And also, what's the relationship with CVMs to Intel Xeon?
Oh, well, the confidential VM is made possible largely through the silicon innovations, right, at the hardware level. And this particular property was not available in earlier CPUs. So Intel Xeon is just the family of CPUs from which that you need to acquire, or more recent one, something that is more recent than it, in order to be able to have access to confidential computing.
Okay, yeah, that makes sense. And I think that's also maybe another benefit that I guess we kind of touched on, but it's not like we're locking people into these these particular evil hardware vendors. It's just Canonical is a software company. We want people to use our stuff. At the moment, these confidential VMs are only available on certain pieces of silicon. The Intel TDX and the AMD CEV. If people produce other hardware, then we would happily work with those hardware vendors and support them to make sure that all the features that they provide, we can then have Ubuntu and plug in and have that seamless journey. And we're certainly working with a lot of partners in the the ARM64 space and the RISC-V space to make sure that as they bring new platforms online, we can have them fully supported.
No, that's a really good point, Henry, because it's definitely architecture parity, and it's a principle that we go with. And for confidential computing, it's just a matter of whatever hits the market first, because we believe in confidential computing, added value to the security posture of users' workloads. So for the moment, there is not yet an ARM confidential computing hardware on the market. When that will come to the market, we will also work on making it enabled and available for users to consume through Ubuntu. And the same for RISC-V and any other silicon innovation that we come across.
Okay, I guess can we just move forward to the last slide, please, as well, and then that will show details of what we've got coming up. So our hot topic will be covered in more detail on February the 22nd. And also, if you're based in the UK, we're going to be present at the State of Open UK, OpenCon UK in London, February 6th to 7th. So that will be a nice collection of other open source enthusiasts and people involved in the community. So do pop along if you can. I think it's worth noting that, I know this is UK specific, but the UK government is going to announce an open consultation to shape AI policy, and they thoroughly recommend people coming to this event to try and keep up to date. So if you can come along, find us there and say hi.
I see here a comment about if somebody is interested in discounted or free tickets, they can email admin@openuk.uk and mention Canonical.
Okay, cool. Well, I think that's probably wraps it up then. If you feel we haven't answered your questions correctly, just get in touch via LinkedIn. Hopefully you can see, or you can email us directly. You know, we are real people, even if we might be quite busy and not respond straight away. But yeah, we're very happy to engage with people and see how they like to use Ubuntu, or what we could do better to sort of support people on their open source journey. So I guess, yeah, there we are. Some links and some email addresses. So thank you very much for attending. I hope you've got something out of this webinar, and we hope to see you again soon. So have a good day.
Absolutely. Have a good day.